Metals and minerals. Our future depends on these natural resources. Renewable energy, green technologies, sustainable cities, they all demand metals. To stop the Earth from overheating, we need to mine. When we do it right, mining transforms communities. But when we don't, people and the planet suffer. That's why ICMM has never mattered more. We're here to guide the industry to mine ethically, sustainably, and safely. We call this mining with principles. Our work covers 4 areas. Environmental, to preserve nature, respect protected land, and take climate action. Social, to enable healthy, diverse, and thriving communities. Governance, to make sure everyone is able to enjoy the benefits of natural resources. Innovation, to push for progress on key mining sustainability challenges. By mining with principles, we bring positive change for everyone. And you can be part of it. Care about where your metals come from. Champion mining with principles. Collaborate with us to build a safe, just, and sustainable world. It starts with responsible mining. ICMM, mining with principles.
But maybe we could start some introductions, and that way we can get everything flowing. As moderator, I'll ask Andrew Keith to begin.
Good afternoon, evening, or morning, everyone who's joined us from wherever you might be in the world. I'm here in Brisbane, Australia, where the sun is just coming over the horizon, I'd like to start by acknowledging the Turrbal people, who the traditional owners of the land from which I speak to you now, from Brisbane, Australia, and acknowledge their elders past, present and emerging. Welcome to this session, which I'm very excited to be able to moderate because it's a great passion of mine, the importance of technology and innovation in maintaining and developing a sustainable world. Welcome to in particular to students or younger people who are joining us to see the opportunities that there are to improve sustainability in our industries. And we've got a strong panel today of 4 speakers who are going to cover a number of aspects of that, some very varied and interesting aspects of sustainability in industry. To start the session, I'd just like to show you the Oxfam donut, which shows a safe and just space for humanity, being the donut in between a social foundation, where we need to maintain and lift people's lifestyles all across the globe, so that all people have the sort of lifestyles that perhaps we are used to having. But while doing that, we need to be mindful of the environmental ceiling that if we go beyond, we put our very environment and our earth at risk. And so technology and innovation play a critical role in giving us the ability to do those 2 things at the same time, to achieve more for people and for the world while doing less harm. So it's in that vein that I'd like to commence our panel this morning, and I'd like to do that by just starting by getting the panelists themselves to give a very brief introduction. to themselves, who they are and who they represent, and then we'll get into the presentations of the panelists themselves. So perhaps we might start with you, Andrew.
Yeah, hi, I'm Andrew Jobe. I'm the founder and CEO of a company called PlotLogic.
Thank you, Andrew. Who's next? Alison?
Hello, thank you for having me. My name is Alison George and I'm the Head of Programs and Initiatives at an organisation called Development Partner Institute.
Carl?
My name is Carl Weatherall. I'm the Executive Director and CEO of the Canada Mining Innovation Council and also the President of Rethink Mining Ventures. Thank you.
All right, great, thank you. Douglas?
Hello there, everyone. My name is Doug Morrison. I'm the President and CEO of the Centre for Excellence in Mining Innovation, based in Sudbury, Ontario and Toronto, and I'm also the Director of the MICA Innovation Network.
Thank you very much, Douglas. We'll move right on, and perhaps we might move then on to Carl then to talk about an overview of Rethink Mining and how it addresses the sustainability issues in the mining industry. Carl.
Awesome. Thank you, Andrew. Hopefully you can hear me okay. I do have a couple of, we want to talk about doing. So I'm going to share a couple of things about how we're doing it. So don't worry, I'm not doing a 50-page PowerPoint. So basically, how are we solving sustainability issues in mining? Before I get started, again, I'm looking at this as an address primarily to students. I want to reiterate that I'm a chemist with very little mining experience. I've worked in mining companies and consortiums, spent time as a co-op student many, many years ago in the 80s. At a mine site and lab, but much of my experience has been solving complex business problems in consortia in other industries like software engineering, microelectronics, aerospace, and defense, and photonics. And I'll bring that back in a few minutes. So the reason I came to CMIC 10 years ago, almost 10 years ago, was that it provided the opportunity to transform the industry, and that's precisely what CMIC is all about. Simply put, we're rethinking mining. Now, our approach is really ambitious as we're moving mining towards zero waste industry with a focus on energy, water, and environmental footprint. You know, net zero, everybody's focused on net zero carbon. Net zero is relatively easy. Zero is hard because many believe that zero waste, whether it's energy, water, environmental footprint, is impossible. And that's exactly what we're trying to do. And the principle that we're working on is based on zero harm. If we can aspire to zero harm, why can't we aspire to zero waste? And we're looking at these three things because of three main reasons. One, and Andrew, you talked about it, the alignment with humanity. If you take a look at the top issues in humanity today, energy, water, environmental footprint, we're aligning with humanity. We're aligning mining companies because energy, water, environmental footprint align with every mining company around the globe. And also it aligns the business units of mining. So energy, for example, is critical across the entire chain of mining. And we do this, we aspire to transform, we're actively transforming the industry by using design thinking to collectively challenge existing paradigms, challenge what is possible, how we can do this, how we can solve these together, and also with whom. Now, it's really funny, I vividly remember a meeting of 9 mining companies talking about ore sorting. We had base metal, precious metals, oil and gas. And at the start of a 2-hour meeting, they were saying, we need 3 separate consortia. Gold has nothing in common with oil and gas. Oil and gas, we have nothing in common with gold. And at the end of those 2 hours, it was stunning to hear one of the participants say, I had no idea how similar our businesses actually are. What I've learned today, I can take back to my business. So it's not just important about what you're doing, but also how and with whom. And what we've done is we've adopted proven methods from other industries such as aerospace electronics, software engineering, microelectronics, including our business model, our collaboration model, even IP. Our IP models are quite advanced compared to many others in the mining industry. So as one large mining company stated just a few months ago, they've never seen a collaboration model like this in the industry. Everything we do is about consortia of mining companies and others to co-develop and co-deploy new platform processes. We aren't interested in a 2% change. We're interested in, can you change that entire process or that technology that's been in place for 90 years and make it 50 to 100% change? And we don't just talk about it, we actually do it. So 5 years ago, we challenged the industry, can we create a new grinding technology, for example, to reduce energy in grinding circuits by a minimum of 50%? And it's really interesting. We were told that's impossible. It's never been done before. It can't be done. You don't understand mining. What's a non-mining guy doing running a mining organization? 5 years later, we not only did it, but we actually have an operating prototype. And here's an example of the prototype that was filmed just a couple of weeks ago. So it gets even better. So that just shows that we don't just talk about it, we challenge the paradigms. We say that's impossible, we're going to do it anyway, and we do it by doing co-development approaches and managing IP different ways. But it gets even better than that, because we ask, can we use that same platform technology and retrofit a ball mill? And it went from a question to an operating prototype in less than 2 years. So this operating prototype, the first prototype is expected, it's measuring the energy consumption now, 72%, not 50%, 72% energy efficiency, energy reduction in grinding circuits. This one has demonstrated 30+%. Our next iteration is going to have 42%. And a reason why we're achieving such high percentages is we use modeling and simulation to actually design these things before we build it, instead of building 5 or 6 different prototypes. And this is just one example. I wanted to show you something real. This is just one example of new technologies, of 15 consortia we have in production right now, creating new technologies around the world. I'm sitting in Canada. However, we work with people in Australia, the United States, Saudi Arabia, Chile, and Europe. So we're sitting here globally doing these things with all sorts of different technologies, addressing zero waste. And recently, we launched Rethink Mining Ventures, a for-profit subsidiary of CMIC that's aimed at accelerating the commercializations of technologies like this. And in fact, we have our first startup. So that's how we're tackling sustainability. We're rethinking the entire mining business, how we can do it, who we can do it with, accelerating the co-development of new technologies to transform the industry. And if you're a student wondering if you should get into this business, are you ready to transform the industry? Because we need people like you. And I'll stop there. Thank you.
Thank you very much, Carl. Very inspiring talk there on innovation and bringing innovative concepts to reality very quickly, and so that's really excellent for the industry. So we'll get Andrew Job in the meantime to talk about the Plot Logic story and his story about coming from academia to set up Plot Logic and the types of projects, real projects that they do in the industry. Thanks, Andrew.
So yeah, I have just a few minutes to talk about some of the things that we're doing in the industry and how that's impactful. In the interest of time, you can sort of see a little video in the bottom right-hand corner, and I'll get to that in a moment. But essentially, it just shows an ability for our technology to go into an underground mine. This is an underground working mine, a large-scale iron or copper gold type deposit. So for those familiar with the industry, very large-scale, highly mechanized mining method. Producing, this is one of the largest copper producers in the world. And essentially, the challenge and what we're using is this to really uplift the performance of that operation. And I guess the question I always get is sort of, how did I get to here, and why is that relevant for what we're doing in industry? So I've got a background in the mining industry, started off as a mining engineer, been working in the industry since the late 90s, and I've always been challenged with this idea, which is a consistent theme in this world of sustainable development, and from an industry insider's perspective, looking at how we can actually supply the world's resources without essentially just screwing up the planet along the way. So it's a really important challenge and something that has not actually been fully addressed at all in the history of the industry. So the industry, has in packets or pockets, had a bad reputation for causing environmental harm or not taking enough care for the environment or doing things in a very sophisticated way. And in some regards, that's well and truly deserved that reputation. So I looked at this as an opportunity to really do things differently. And people asked me if I had an epiphany moment about this particular type of technology we developed, but it certainly wasn't the case. It just started from a first principles approach of working in industry, and then getting into more senior roles and always being challenged with this nagging thought about how we can do things better. And so essentially what ended up happening is 2016, I quit my job. I went and did a PhD for a few years to dive into this in a lot more detail. Got to 2018 and then worked out that there was a really good entry point for the business that we're trying to establish. So went off and started the company, did a whole bunch of fundraising out of predominantly out of North America. And then 4 years later, it's gone from me to now we're 75 people in our business and growing all the time with deployments in South America and North America, as well as Africa, Asia, and of course Australia. And essentially the reason why this is super exciting is, what we're doing is we're going and taking this idea of doing significant uplift to mine performance. So not just incremental improvements, but we target a minimum 20% uplift in performance of those mining operations, every mine we touch. And to do that, superficially you go, okay, well, let's implement some tech and it'll work kind of nicely. But the next layer down is really where the difficulty comes in. And so one of the reasons why, going back to this point about how the industry has performed in the past, one of the reasons why it's been so difficult is we have to branch lots of different areas in order to come up with something which on the surface might look like a reasonably simple solution. So for us, what we do is we go into a mining operation, we provide sensors across that mining operation. So we start with essentially drill and blast. We have sensors that collect information on every single hole that before it's blasted to give some sort of rock mass property. We then go and scan all the exposed mine surfaces on essentially a daily basis. And what you're looking at in the top right corner is a underground mine drive development. And then we also do the same thing over conveyor belts to give real-time feedback on the material as it's flowing through the business. And then we're adding in new layers all the time into this platform. We've got a shovel-mounted system and also a downhole logging instrument that will be rolled out in the first quarter of next year. And to put these things together requires essentially two really major pieces. And the third piece, which is the domain of the mining industry, which is another piece which isn't included on this little plot, but is also equally important. The first one's field robotics. So getting to, if you're super keen on coming into the industry and doing things that are really quite sophisticated, then from a field robotics point of view, this is absolutely an engineer or scientist playground, because we work in really complex environments, often GNS denied, which is the case of the underground environment here, where we've got to essentially use different mapping techniques to position ourselves in 3 dimensions and time very quickly. Also very low bandwidth, so a lot of mines have very poor communications. We're working in really rugged, hostile terrain. So think of the Elon Musk robot that he promoted the other day. They're putting that into an office/workshop environment. So very controlled terrains where we're working in really tough, hostile terrains. It could be minus 20 degrees Celsius, that is, apologies for North Americans, up to 40 or 50 degrees Celsius, really dusty, etc. So we've got to be able to do that. And all at the same time, that has to be done in low latency, high reliability environments. So we need this equipment to work 24 hours a day, 7 days a week, because that's how quickly and how often the mines are working. And of course, we're using sensors that are right at the cutting edge of physics, essentially. So what we do is we take sensors that work in the infrared part of the spectrum, as well as LIDAR and some other things. So these are, what were laboratory sensors used for very sophisticated laboratory projects, and said, hey, how can we actually run these in a rugged mining environment so they can deliver things at scale? And that's just the first part. That just gets us to a point where we're actually collecting information, massive amounts of information, that is terabytes in fact each day. And then we actually have to do something with that information to drive a decision for the mine. So we take literally terabytes of data. We've got to find ways of storing it, labeling it, and then processing it. And going back to the point of GNS denied environments, we're doing that, you know, both on the edge and in the cloud. Often we're running those techniques in parallel. And then on top of that, because of the type of data we're getting, we have to use really very high dimensional AI techniques. So we're using, you know, if you think of people that have had some exposure to artificial intelligence, where you're doing computer vision or recognition of images, you know, cats, dogs, etc., in a photo, you know, that's really just looking at 3 color channels. We have, you know, 600 color channels essentially, which work in the mostly infrared part of the spectrum, so the parts of the light spectrum you can't see. And that's important because what looks like a grey rock, or in this case a red rock for you and me, actually has a lot of different characteristics in that part of the spectrum. So we've got to process all that information super fast and run these really cutting edge AI techniques that can actually make determinations of those rock properties. And then of course, even just within that, the data preparation is really at the pointy end, because we have to deal with lots of changing environmental conditions. So huge amount of things that need to fit together. We've got in our team of 70 people, you know, 60 of those have come from an engineering or a science background, and really working on exciting products that have never been developed before and have a real impact on the industry in terms of increasing the amount of yield that goes through the mining system, and at the same time reducing the energy consumption. So back to other Andrew's point of essentially doing more with less and using really cutting edge technology in order to do that. Thank you.
Excellent. Really inspiring stuff. Thank you, Andrew. We might move on to Doug while we're just waiting to get Michelle's slides set up. So Doug's going to talk to us about minimising tailings from mining, and some plugging in of tailings into the circular economy through reuse. So making the most of our resources. So over to you, Doug.
Hello to all you young people who are listening, or I hope you're listening. The reason you want to be involved in this business is because it's simply the most important business on the planet at the present time. Because we need a lot more metal and a lot cheaper metal, and we have to produce it faster than we ever have done before, and we need the help of young people to help us do that. My organization at SEMI is trying to improve the productivity of mines, taking that red line to the position of the green line, moving it up and to the left. But and that usually would improve the net present value of the project. In the case of tailings deposition, we're actually trying to stop it from getting worse and worse. And the reason for that is because, in actual fact, the length of time it takes us to get approval for the tailings and waste management facility is getting longer and longer, and that is eroding the value of the project. It takes us too long to get permission to open up. And that's because the local communities are concerned about land and water access. They're concerned about the health risks, and they're concerned about the safety risks of the tailings storage facilities that the industry typically uses. Typically what we do is we take a single waste stream from the mill and we put it into a tailings pond in a technique that's called subaqueous deposition. There's a huge water retaining dam, and there's always a possibility that it might fail. It happens very, very infrequently, but when it does happen, it's a pretty bad situation. And so we have management during operations, but we also have to have post-closure management of these facilities, not because they're badly designed, but because they have to last for thousands of years. And so that means that the probability of failure of these kinds of features is very high, very close to 100%, if we leave it there forever and ever. So the alternative that we've been using recently has been something called dry stacking deposition, where you take as much of the water out of the facility as you possibly can. That means you don't need a water retaining dam, so you can't have a catastrophic failure. But what you can have is you can have fugitive dust, which is toxic to the environment and to human beings. And when that escapes, that gives everybody a health problem. You can use a vegetative cover on the top, and we've done that in Canada. But what we found in Canada is that after 10 years or so, the roots of the plants all penetrate the organic cover and make it down to the tailings. and then the toxic material in the tail kills the plants, so they dry up and fly away, and we have to repeat the whole process. So it's not a permanent solution for managing our tailings. My colleague and I, Vern Raleigh, wanted to come up with a full and final mine closure plan where there's no risk and no cost or liability in the future, and where the probability of failure was 0. So that would mean no post-closure management and no hazardous deposition left behind. And what we discovered, or what he discovered, it was all his work, Vern, who basically discovered what you have to do is you have to split the waste stream into 2. And he explained to me that in actual fact, something I didn't know, that 80% of the material in a typical mine tailing is completely benign. And you can put that into a pile once you've separated the benign material out from the contaminated material, which is roughly 20%, and you can store those in 2 separate locations. One is tolerably benign, we call it, and it's tolerable to the plants, which means that the plants are perfectly happy to grow on top of it with no problem at all. The highly contaminated concentrate pond, of course, has to be processed. We can actually turn the tolerably benign tails into completely benign tails by using an engineered eco-bioreactor, which is using microbial action to purify all the materials and all the water in the facility, and that then makes that a completely pure situation. There are other processes we can apply to the 20% on the other side. These are industrial treatments. Some of them will actually recover the additional value left in the tail, so that's value recovery. There are some that will convert the materials like the arsenal pyrites into an inert material, and that's a process licensed by Dundee Sustainable Metals. So that solves that problem, and that basically the rest of the material in that material is solid waste, and that goes into the pond on the right-hand side and can be reused for almost any application. So by separating out the waste stream into those 2 groups, we can actually solve and resolve all the contaminants in the tailing system that we have at the present time and leave no hazardous material behind at all. Now, I don't want to spend any time on the actual process. The important thing here is the material on the right-hand side, which is the alternative use of the sand, silt, and clay materials, which are essentially basalt rock ground down to sand, silt, and clay size. These are the mafic minerals, the black minerals that come from rocks. And what we discovered in the last 2 years, and it was again Vern's work that discovered this, was that mafic minerals are actually slow fertilizers. And what we found was that the plants that were growing on top of our waste material were growing faster and stronger than the plants on our controlled material that didn't have any basaltic waste product in the mix. So in other words, the rock that we have had tied up in these tailings for decades is actually beneficial and helps more plants to grow faster. And that relates back to some of the things that one of the speakers this afternoon talked about, which is Carlos Nebras talking about not just stopping deforestation of the Amazonian rainforest, but actually reforestation of the Amazonian rainforest by using higher fertilized soils. And we've also just in the last 3 months discovered that basalt can also replace, by reprocessing the basalt, you can actually replace part of the steel and the concrete that we use in other industries. And that's a replacement with 0 carbon dioxide release. So another benefit that's coming out of this kind of work. So basically, instead of having the kind of legacy that you see on the left-hand side, which the industry has left behind for the last few decades, we can actually produce an environment like this one on the right, where we've actually produced now a permanently stable green vegetative situation, which will absorb carbon dioxide, generate oxygen, fix nitrogen in the soils, and will generate food or wood, or actually just very pleasant plants for us all to enjoy. So what we're trying to do here is not just to solve the mining problem on the left, but we're actually trying to generate revenue, create a revenue generating enterprise on the right hand side, and create a perpetually sustainable outcome for what previously was a very negative outcome. And that's it. I'll leave you to the next speaker.
Thanks very much, Doug. That's really exciting stuff for someone long-term in the mining industry, like me, who's had to deal with the challenges of tailings on different mine sites, and I can foresee lots and lots of applications for that everywhere around the world. That's really fantastic. We might move on now with Alison, who is going to tell us about something called a research battlefield. So I'm really looking forward to hearing what that's all about. Over to you, Alison.
Thank you very much. It's really interesting to hear all the speakers as well. So thanks very much. So as I mentioned, my name is Alison George. I work for the Development Partner Institute. And really just to say a little bit about the organisation so it can contextualise what I'm going to talk about. The Development Partner Institute is focused on accelerating mining for development and making mining work for society as well. And as a result of this theme underpins all the programs that we have. And we focus on trying to bring the voices of communities, of youth or emerging leaders to the fore, as well as women and groups that are traditionally marginalized from different conversations, especially technical and perhaps in what's classed as innovative conversations as well. So with the idea of doing no harm and of course zero waste, one of the things that we created this year is called the Mining Innovation and Research Battlefield. I'm not sure if you're familiar with Mining Indaba, which takes place in South Africa in February, but this year it was in May. So we created this battlefield idea. It's based on the investor battlefield, which runs where we would have young people, researchers, and sometimes academics, supported by academics, to collaborate with industry and bring new ideas to the fore of the emerging leaders. So if you imagine Dragon's Den or Shark Tank, we posed the question this year, which was developing sustainable post-mine economies. And we invited people globally to respond to that. We contacted universities across the world. We did prioritize Africa to some degree because Mining Indaba takes place there. And we invited people to give their ideas as to what this could mean for them from a sustainable development angle. So we had lots of different applications which focused on recycling, which focused on building post-mine economies and sustaining communities through regenerative agriculture of industrial crops, different systems thinking, so mine design for sustainable development, ideas around the establishment of activated carbon for manufacturing plants using coconut shells. So really it spanned whether it fell into the bucket of environment or social development or economic development. So we cast this wide net, and we had 2 rounds, and the young people then pitched to different panel members from industry. So we had BHP, Africa Development Bank, Anglo Gold Ashanti, so lots of different players who wouldn't always hear new research ideas from these young people. And we had people that had applied as well that came from mining communities, and it would be really difficult for them to speak directly to a mine about their ideas about developing their community or transforming their community as a result of mining. So this is what we termed as innovation, because the ideas were then, you spoke, I think, Andrew, about your PhD. So imagine having your PhD now turned into something real. So we also offered an innovation grant of $28,000, which for some people is a lifeline and completely transforms lives and can transform ideas. The 2 ladies that won this year will also be speaking at the LIAMforum, and their idea on regenerative agriculture of industrial crops was what was successful. Next year, we plan to pose a question on artisanal and large-scale mining. So we pose really what's arguably complex questions, and we invite young people to give their ideas. And it doesn't have to be just researchers that are PhD students. We ask for people from mining communities, but we do suggest that they're backed by an organisation or that they're open to working with different organisations. So that's one of the things that we do, and we plan to do this on an annual basis and take it worldwide. So the innovation and research battlefield is something, when I look at the ideas that are being presented here today, you know, the young people that got up on stage and also had lots of very simplified ways of addressing quite complex problems, it was really, really encouraging. We also focus on, I didn't say I'd talk about this, but just to show the theme of the work that we do, we're now having a series of dialogues focused on responsible sourcing. And we've taken this to a number of different countries. And again, we request and have in the dialogues communities and young people, and for them to give their ideas, because by 2040 or 2050, when we have some of these ambitious targets, they will be of age or suffering the impact or benefiting from the opportunities of the innovations. So that's with young people and emerging leaders. And it's really been very, very rewarding to see the different transformations and to see the ideas, but in particular, to see the shift of the industry. Normally people can say, oh, it's, you're not a mining person, but we're seeing lots of people come together to collaborate and solve multi-stakeholder dialogue. And that goes beyond just having government, the private sector or communities in the room, but different types of voices within the industry across the value chain. So different types of community representatives. And we always ask the question, to what extent are you representing the community? So the dialogue goes deeper and it's not so much, what's the best way of putting it, but it's less politicized and more focused on solving problems. So that's a little bit about us. So really we're focused on developing mining for society, mining for development, and really passionate about bringing new voices into the fold, given where we find ourselves today. So that's it from me. Thank you.
Thanks very much for that. And Alison, it's really interesting way of getting new ideas into the industry, and so we really appreciate your contribution. So now we're going to call on Michelle, who's going to belatedly give her keynote presentation, but I'm sure it's going to work really well, because what Michelle's going to talk to us about is the 5 systemic issues around sustainability and the mining industry, and so I think with the presentations we've had that address different aspects, that Michelle's keynote presentation here is now going to draw all of that together and tie it up in a nice little bow. No pressure though, Alison, Michelle. So over to you.
Thanks. Thank you. And actually, I'm really appreciating going last, because I got to hear some fantastic ideas from everybody else. And Alison, it's great to hear that we are doing some work to not only bring different ideas into the industry, but also really deepen some of the conversations that we're having with community governments and those that are part of our industry, but sometimes a little bit peripheral as well. So that's very exciting. And I've actually worked with Carl for many years, so it's always nice to hear some of the things that Carl and the team are doing. And Andrew, I know some of the optimization work that you're doing is really exciting. And Doug, and again, we'll talk about it, but one of the key challenges that we have in the industry is really how do we become more sustainable, and how do we use some of the products more completely that we have. So I'm going to talk a little bit about innovation in mining. Try to touch on this sort of fairly quickly because it's a massive topic. Very happy for anybody to reach out to me afterwards. I'm not only on LinkedIn, if you go and look for Michelle Ash, but you can reach out to me at Oz Minerals. I'm the technology executive at Oz Minerals, and so some of what I'll talk about, of course, will be sort of technology relating. Look, I would also like to just quickly acknowledge the traditional owners and the First Nations custodians of the lands in which all of us are on today. and would like to acknowledge their leaders, past, present and future, and as well acknowledge the contribution that they make and are continuing to make, and allowing us to be here and having this conversation. So look, there are a number of megatrends that are impacting not just the mining industry, but the world in general. So look, there are a number of megatrends of which I'm sure you're all aware that are impacting mining and all of us. So this move to adapting to climate change, decarbonisation, which is pivotal to what mining is able to not only help the world with, but we're doing a lot of things that are actually at the forefront of creating not only alternative energy grids, creating of the metals that go into all of those products, driving some of the industrialisation of battery electric vehicles, etc. A lot of what the presenters, others presenters have spoken about around leaner, cleaner, greener. We want to drive much more sustainable outcomes. Health imperatives, and certainly in the mining industry, always safety has been fundamentally important, but now even more so trying to automate a lot of what we do so that we can take people out of those dusty environments, those industrial environments, and have them, you know, monitoring, advancing, optimizing, being creative in more sort of office environments. Geopolitical shifts, which we've seen unfortunately dramatically play its way out in the world, really trying to think through how do we bring some of these industries back onshore. And, you know, again, the industry is doing a lot in that space. Driving digital, and you've heard Andrew as well as others talk about those sort of digital aspects and some great technologies that are solving really interesting problems. Increasingly autonomous, which I've spoken about in terms of how do we automate what we do. And then of course, this whole issue around unlocking the human dimension, which not only Alison spoke really, I think, very eloquently about, but also how do we engage actively with, and it makes it a lot more complex, but with all of the different people around our industry. And so these are really shaping some of the thinking in our industry. So if we then go to the key problems that we're trying to deal with in mining, there are 5. And those 5 are global ore body intelligence. So we do not know where there is enough nickel, especially, but even some of the copper reserves. We're using more copper than we're finding, you know, gold, etc. So a number of the minerals, we're still really needing to accelerate the rate at which we can find those minerals and find those elements. And so this is really around how do we increase the rate at which we find. So how do we double the rate, 10 times the rate at which we find ore bodies? How do we find them down to the last gram and to the last metre? Because one of the things that really drives a lot of the waste in our industry and a lot of the challenges around planning is that we don't know enough about our geology. You know, we think that the ore body is going left, but in fact it's going right. We put, you know, infrastructure sometimes on top of our ore bodies. So global ore body intelligence, really understanding how did these ore bodies, how were they created, where are they? Autonomous and electric mining, as I said, you know, driving significantly better health issues, being able to access a wider range of people who, you know, can't necessarily be located around our mines, getting access to really talented people, relies on driving not only autonomous, so that we don't have people you know, at the coalface, quite literally, but we have them in office environments and other environments where they can really excel. And how do we drive the electrification of our industry? So not only in terms of removing diesel engines, but also thinking about alternative grids. And I think this is where the industry really is leading a number of the other industries around, you know, how do we do some of these things? Precision extraction, and I think this is the Nevada. So whilst everything that Doug said around if we do produce waste, how do we not only produce less of it, but then how do we repurpose some of that waste so that it is no longer waste, but it's a byproduct that we can use. But if we could, the most ideal thing that we could do is just take the metal that we're interested in, leave the rest of the ground intact, and just take what we need. And this would be quite a radical change to the industry, because as some of you most probably know, in some parts of the industry, you know, copper, gold, we move 11 tonnes of waste for 5 grams, which is about the size of a wedding ring of gold. In copper, it's around about 10 tonnes for about 100 grams of copper, and we all need copper in our houses, cars, electronics, etc. So how do we just precisely extract what we're looking for? And I'll talk a little bit in a second about an example of that. Symbiotic development, this really goes to the heart of what Alison was saying. How do we actually co-design, co-develop with our communities, with our governments? How do we share the value much more equitably? How do we build sustainable long-term futures for the communities and governments around us? And then how do we think about disruptive business models? Because the business model of mining is changing and it will change over time. If we go to the next slide, so I won't touch on this too much, which is really around Oz Minerals, but you'll see there when you see it that Oz Minerals, we're very much around creating value and creating value for all of our stakeholders. So not just around shareholders, but communities, governments, suppliers, because we want suppliers to be with us long term, customers, and very importantly, our workforce. You can look at the strategic aspirations there, and I would encourage you to do that. And again, reach out to me and let's talk about some of these more. But they are around driving zero waste, zero water, having no people in the operation directly, but having them able to work virtually, flexibly in a more office style environment, yet still drive the outcomes. So a lot of really interesting things that we are aspiring to. If you go to the next slide, you'll see if you come onto the Oz Minerals website, so one of the things we're very active in doing, and I think this is how we solve some of these problems, and it's really what the others were talking about today, is none of these problems can be solved by a single person, by a single organisation. They are big, they are complex, and they are challenging. And so creating consortiums and groups of people try to access the 8 billion people on our planet, and the thinking of those 8 billion people is going to be fundamentally important to solving these problems at speed. So if you come onto our website, you'll see that there's a virtual cafe that you can see in the slide there. You can go into that cafe, you can see some of the really interesting problems that we're trying to solve and that we're trying to get consortiums and groups of people to solve. Some have prizes associated with them, some have other reward systems, some are really for the good of the planet. If you go to the next slide, again, you can see some of the sorts of challenges that we've been working on with some of our ecosystem partners. If you log onto the QR code or use the QR code, it will take you to some of those white papers, which are starting thinking and thinking that we want to build on and we want the world to build on. And then you'll also see some active challenges that we're working on. A number with people on this call, and I know Carl and his team at CIMIC are helping us with a number of those challenges. So we're very excited about that relationship. If you go to the next slide, I just wanted to touch briefly one of the challenges that we're doing at the moment, which is around in situ leaching. So this goes back to precision extraction. The idea around this technology is for us just to be able to take the metal that we're interested in. So using a series of drill holes and solutions that will then dissolve the metal, being able to bring that to surface. And so the surface looks exactly the way it had when we first started. And in fact, when you finish the in situ leaching, you can just plug off the drill holes, and you can then continue using that ground for its agriculture or its original intended purpose. This is a partnership that we're doing with EnviroLeach, the particular trials that we're undergoing at the moment. It's actually at a town called Kapunda, which is in South Australia. And in fact, it was originally a copper mining, so where this is for copper, a copper mining town in the 1860s. A whole heap of Cornish people came out and established the copper mining industry in South Australia. So we're in fact bringing this town back to its roots. And it's been really interesting talking to the community, talking to the townspeople about how excited they are that, the industry that their grandfather and their great-grandfather was in is now coming back. If we go to the next slide, a very complex slide, I'm not going to spend a lot of time on it, but there are three major challenges that we're trying to work through with in situ leaching and this trial that we're doing at Kapunda, and a very exciting piece of work that the team are working on. So if you go to the next slide.
We might have to wrap up, Michelle, yeah. I'm afraid. We're just about out of time and about to come to the next panel. So
exactly. So this is the last slide, and it's really just to say, contact me, reach out, and we'd love to engage in any ideas that you have. So thank you for that.
Thanks very much, Michelle. Thanks for an excellent presentation covering a lot of ground. And it's really interesting to see a mining company reaching out for solutions from the broader community. So that's very encouraging. I'd like to thank all of the speakers we've had on the panel. It's been for me a very interesting session where I've learned a lot of things. So thank you to Alison, Andrew, Carl, Doug, and of course to Michelle.